Has anybody figured it out?
Shouldn't it be 5?
5C3? Oh, the 5C3 over 20C3. Has anybody checked it? I don't think it works, right? Doesn't work. Any ideas? Anybody tried 5P3? How about permutation? Does that work, Dean? Nope, it doesn't work. Here's the one way it would work. You ready? The one way it would work is if we did 5C1. If we did them separately. No, not C. It had to be P. It had to be P. Which would be the same thing as, technically, 5P1 over 20P1 cubed. Because we have to deal with each of the events separately, sadly. Because remember, doesn't permutation take into account counting down? No repetition is allowed. Because permutations, you have a set number of objects and you're rearranging them. And if there are repeats, you'd have to divide by those repeats. So for permutation, this computer wouldn't be allowed to use the same number 3. We couldn't use 5P3. Even though the order is important as far as the numbers, we couldn't use 5P3 because repetition is allowed. So I'd have to deal with them separately and say, okay, how many orders of the 5, how many orders of the 5, how many orders of the 5? I have to think about them separately because the repetition is allowed. I can't just say 5P3, sadly. And the same thing goes for the denominator. So in this sense, I don't think it's easier to go to permutations, and combinations don't even work. I don't think it's easier to go to permutations. It's actually kind of harder, isn't it? It was easier just to say, like, oh, hey, there are 5 different options. So what's the chance of the computer getting one integer that's less than or equal to 5? Well, 5 out of 20. Cool. Just cube it, because it's going to be that same chance over and over and over again. Why is that something that should, this idea, why should this discourage gambling with something like a slot machine? A, your chances are really low, and B, okay, some machines might be rigged. I totally am not saying that they never are. But theoretically, if you pull the handle, just because you got it wrong 20 times in a row, are your chances any better of getting it right the next time? Not unless it's rigged, then who knows? Like, it might be like, oh, hey, on the 100th or the 500th or the 10,000th time, you can let them win. But besides that, the chances are exactly the same. That's also interesting when we're talking about baseball stats. Have you guys ever heard of a batter being due?
Always drinking. They think that he's got it in suit.
Yeah, it's like he hasn't gotten whatever in a long time, so he's due. He's due for a good one. And it doesn't have to just be baseball. But there's something about like, oh, someone's being due because, oh, it hasn't happened in a while, so it's bound to. Just because it hasn't happened in a while doesn't mean your chances are any better on the next one. Now, are there things like stoplights and the timing, and so it might be where the event outcome might affect the next event's outcome? If you hit this light red and you see that one turning green, you're like, okay, I probably won't hit it, right? Like, there are times when one event will definitely affect the outcome of the next event, but to some extent, there are some things in life where it's like, oh, I'm due to, or like lotto tickets, I'm bound to eventually. Your chances aren't any better. If you buy a lotto ticket the next time, are the chances any better of you getting like the right numbers? Or if you do one of those, like, what's that one? Yeah, is it Powerball? The one where they spin and then the numbers pop out. Just because whatever numbers you have haven't popped out the last however many times doesn't mean you're due for them to pop out. Anyway, The chances are exactly the same for this computer every single time, which is why if I were to ask you to randomly generate a sequence of 10 numbers, or randomly order, maybe like ones and twos, you could do that. Randomly order ones and twos, like a computer program would. Why is it really hard for people to randomly order anything? Because you see what's coming out, and you're like, oh, it looks like a pattern, I need to change it. Or, oh, wait, it doesn't look like a pattern, I need to make it. Like, you see what's there, and so there is no way of you actually randomizing anything. Because if you actually had a random list, there would be lots of random groupings together, because sometimes it's very varied, but sometimes it's bound to be grouped together. Whereas if I were to tell you, for instance, this is from actually a TV show, ironically. Anybody watch Numbers? It's a good show. But if I was to ask you to stand up and randomly space yourselves around the room, what would you do?
Go to the corner.
Everyone would go to the corner? That would be random? Would you think that's random? No, you wouldn't think that's random. What would you do if I told you to stand up and randomly space yourselves around the room? Would there be any people super close together? No. Probably not, because you're trying to make it random, and in making it random, you just made it not random because you evenly spaced each other out. And random wouldn't be evenly spaced all the time. Sometimes it'd be clumped together. Anyway, all cool things to think about that don't necessarily help us with this problem, but that's okay. Zoop, zoop. Makes you think. Or, yesterday we talked about and, now we need to talk about or. Yesterday we talked about and, now we need to talk about or. There are two different types of ors that happen. So you guys see two different Venn diagrams as you're taking notes. There are two different types of ors, or I guess two different situations where the ors might happen. Why are the cups? I don't know. The cups were all undone and all over the place. It's okay. As you guys are writing, since most of you can somewhat multitask, but these days it's really easy to spend a lot of money really fast. But that's assuming you would win. All right, long story short, we're going to clean up after ourselves, right? If the creamer ever goes empty and we're the last one to use it, we're going to throw it away? Yes. Go team. If we ever have a cup or a napkin or trash, we're going to throw it away? Yes. Go team. Okay, here we go. Union of events. Or, if there is an overlap, like the black ace, if there are times when A and B can both be true, we have to be careful how we do or, because or says the probability of A or B occurring, which we could say probability of A plus probability of B, but do you guys see any dilemma if we just add all the A plus all the B? If there is an overlap, why could this be a problem? Because you're going to double count any of the overlap. So if I was to ask you something to the effect of, here's a quick example. Let's use green just because I never use it. Example. The probability of picking a black card or an ace. If you were to take this formula outright, say, hey, yeah, what's the probability of getting a black card? 26 out of 52. What's the probability of getting an ace? 4 out of 52. Yay, dun, 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 dun. No, because I just counted 2 cards, 2 black aces. I just counted them twice. And there are only 2 cards. I can't count 2 there and 2 there and say 2 cards or 4 cards. It doesn't make sense. But does it make sense that I do want to take all the black options and all the ace options? So what I need to think about is if there is ever a time where there is an overlap, if there is ever a time where the characteristic can be the same, or I should say the 2 characteristics can be shared, I'm going to call that the probability of A and B. A and B at the exact same time. And I'm going to need to subtract that. Subtract when A and B are both true. So this isn't 2 separate events of doing A and then doing B, of choosing A and then choosing B, of choosing a black and then choosing an ace. It's not that kind of and. It's an and in the sense of when they are both true, which would be the overlap. So 2 out of 52. So your final answer, yeah, wouldn't be 30 out of 52. If you took all the black cards, all the aces, you would not have 30 cards. You would only have 28 cards. Because you would have all the black and then the 2 red aces, which you could go ahead and simplify to be 2 goes in 27 times and 14. I think that's all you got. Because 7 doesn't go into 27. No, 26. Lo siento. Which would be 7 over 13. Thank you, thank you, thank you. That was close. Okay. I reduced wrong. So if you ever have 2 characteristics, if you're trying to do an OR, but they can be true at the exact same time, I am going to take all the black, all the aces, just subtract the 2 black aces. Subtract the 2 that are overlapped. But down here, mutually exclusive events, why would this not need to be as big of a deal? What if there was no overlap? P.S. There is a notation for OR. It's actually a right side up U. So even though we could use the word OR, the notation for OR would be the right side up U. It's technically called a union. You can see up here, a union of events. Careful about contradictory. It's actually not contradictory. I know what you're trying to say. Can anyone give me an example using cards that would be like the second one, where the 2 events are mutually exclusive, aka not happen at the same time? With cards. What would be an OR? Sure. Probability of choosing a spade or hearts. Why is there no overlap? No hearts or spades. They're mutually exclusive. There is no overlap. There are no cards that are both. So therefore, bless you, how would I find the probability of this one? I'd say, well, what's the probability of a spade? Not 26. 13. Probability of getting a spade, 13 out of 52. Probability of getting a heart, 13 out of 52. But there is no need for me to subtract. So sometimes it is just as simple as saying probability of A plus probability of B. Just add the 2 together, no big deal. But I need to be careful every now and then for when the characteristic could be shared. If I just add the 2 separately, I will double count and I will need to subtract one of the overlaps. This one will end up being 26 out of 52, which would be 1/2, or 50%. With that, what would you guys do for this one then? We already basically did this one. Is it really that different than a black or ace? No. So we just have to go ahead and say at the end of the day there's only 28 cards. The 26 red and then the 2 black aces, right? Which will end up being 7 over 13. I think 7. Yeah. Okay. New vocab term. Complementary, not complementary. Wait. You've seen the word complement before. How have you seen the word complement or complementary? Angles, yeah. Complementary angles add up to be, which one? 90. Supplementary add up to 180. I wonder if that has anything to do with what's here. Basically not. Okay, so complement, new meaning in probability. The complement of an event. I guess it kind of applies. We'll see if you guys can get a relationship between complementary angles and complementary events. The complement of an event is the chance that it doesn't occur. The complement of an event is that it doesn't, or the chances or the odds that it doesn't occur. Notation. If we have an event E, probability of E occurring, the complement would be noted, probability of not E. Not E. Listen, not E. Don't write the word not, show the little symbol. Not E. Next to, not on top of, it's not an accent, it's not an enye. Not in this context. It means not E. And the probability of not E, well, hold on. Does anybody know what the chances are of it raining today? I mean, obviously, it's been raining, but does anybody know what the chances were coming into today? 60%? Later today it's higher. This morning it was what? Okay, 50%. That's what Melanie's saying. So if the problem, for sake of illustration, let's not do 50. Someone said 4, right? Okay, maybe it was this morning. Probability of E occurring. Let's say the probability of E occurring was 40%. What's the probability of not occurring? 60%. Second one is the other option. So either E happens or E doesn't happen, right? Doesn't have to add up to 100%. Either it rains or it doesn't rain. Either it's sunny or it's not sunny. I mean, yes, you could say the different times in the day, but in general, if you're thinking about, well, either it is or it isn't. Well, is or isn't has to add to 100%. So if you know 1, subtract from 100.
So the second one should have it.
Oh, I say not. Lo siento. Thanks, Jack. You said it, but I didn't realize I didn't write it. Got it. Of E, sorry, of not E occurring or of E not occurring. I'm putting not E because of the notation. It goes before the E. If you want to be super proper, yes, you should probably say probability of E not occurring. That's much less awkward. But if I was writing a formula for it, I would just say, well, fine. If you know what the probability is of E occurring, to find not occurring, just subtract. From why 1? Because probability is technically a decimal, a really small number, right? So I'd technically subtract from 1. But could you think of it as 100% minus the probability of E, the percentage there? Yes, you can. There you go. The probability of E as a percent. Go team. And let me give you a very practical example, and then we'll do an example. What if I was to go back to that TV example? What if I was to go back to the TV example, where we were shipping the TVs, and what are the chances that you would get like 4 good, or 3 good, or 2 good, or 1 good, etc.? And what if I was to ask you, what is the probability? How many bad TVs were there? 3? I think you were getting 4 and there were 3? Okay. If I was to ask you the probability of getting at least 1 defective TV. Remember the at least? Why was it nastier? You had to add all the different ways it could happen. Because at least 1 bad TV, you either get 1, or you get 2, or you get 3, and you have to add together all the different options. And that was actually a pretty easy example as far as not too many variables. Either you get 1, or you get 2, or you get 3. Could we face that problem by saying, okay, fine, what are all the different possible ways this is true, at least 1 bad? Find all the different possible ways it's true and add them all up. Yes, totally works. But what's the other way of thinking about it? The other way of thinking about it is, think of the complement of at least 1 bad TV. If you didn't get at least 1 bad TV, what would be the situation? You'd be getting all good TVs. So you'd only have to find 1 probability, right? Probability of getting all good TVs. We'd only have to find 1 thing, and then what could we do to figure out the at least 1? Subtract from 100%. So instead of adding up all the different ways that it could be true, we could say, well, when isn't it true? Oh, cool, subtract from 100%. It's all the rest. This is the 1 bit of probability that it can't include. Does that kind of make sense? And that was only when we had 3 objects. Let's see what example we have. Whew, things just got a lot more exciting. Because now, there's 1 faulty for every 1,000 it produces. What's the probability that an order of 200 units will have 1 or more faulty units? how could we summarize the different possible outcomes for this example? A manufacturer's machine averages 1 faulty unit for every 1,000 it produces. What is the probability an order of 200 will have 1 or more faulty units? What are the different ways it could have 1 or more faulty units? They open up all 200 and try them all out, and they get fined. 1 is faulty. That'd be one way. What's another way? 2 are faulty. What's another way? 3 are faulty. Another way. All of them are faulty. It doesn't say that there's only so many faulty. It just says that's the average probability that it will be faulty. Do you see how we'd have to literally go through, okay, 1 is, 2 is, 3 is, 4 is, all the way up to 200 are? Struggle. What would be a lot easier? To find the probability that at least 1 of the 200 are faulty. Couldn't I just do 1 minus the probability of, what's the one time at least 1 won't be faulty? All are good? So instead of figuring out the 1 to 200 different ways this could happen, I could just figure out, oh, well, this won't be true if none are faulty or if all of them are good. Okay, let's just think about that one thing instead of these 200 things. So this one thing, none are faulty. How do we figure that out? Made a fraction, because every probability is a fraction. Do we know for sure how many faulty units are even possible, like that they manufactured? No. I just know the odds of getting a faulty one. What are the odds of getting a faulty one? 1 out of 1,000. What are the odds of getting a good one? But question, how many times do I need this to be repeated? $200 times. Think fundamental accounting principle. You open the first box, it needs to be good. You open the second box, and that one needs to be good. You open the third box, and that one needs to be good. Wait, and in math, what's that operation? Multiplication. So I need this chance, 999 out of 1,000, which seems really, really good, right? Like, oh, super high chances if you get one that you'll get a good one. But what are the chances that all of them will be good? Someone get me the 999 out of 1,000 to the 200th power. Don't subtract from 1 yet. 0.133. Whew, what are your chances of getting all good ones? Not very high. Seems kind of weird, right? So then when I go ahead and subtract, the probability of getting at least one faulty one is going to end up with 0.8661. Good, which would be 80. You could just go straight 87%, or you could do 86.6%. That technically is 3 decimal places, just written as a percentage. So the probability is kind of high that you would get a faulty one? Yeah. But would you think of it just from seeing 1 out of 1,000? You're like, I probably won't get a faulty one, right? Probability doesn't always follow what your mind would naturally think. So wait, why did I do 200th power again? Oh, was something go wrong? Yeah, what's up? 999 over 1,000 is 200. I got 0.8186. Uh-oh. It's okay. Check again. So I have 1 and I have 2. What was it? 0.81? 0.8186. So then subtracting that. Struggle. That's not very high. which makes a lot more sense logically speaking. I didn't think it'd be that far off, but I was like, all right. I trust the math, but I didn't do the math, so that's a little bit of a struggle, huh? All right, that makes a little more sense. I should have asked instead of assuming. We all know the danger of assuming. Like assuming someone else will pick up your trash. Anyway, we come full circle. Okay. Section 9.7. Some of you guys were able to start last night. Did you get stuck? And where? Where? I have it. 8? Wait. Number 8 shows that there's actually another notation for not or the complement. Let's go back to our notes real. Come on. That's so funny. I've actually never seen this before. I didn't notice that the book showed a different notation. The book also shows not with an asterisk. I guess that works. I don't like it as much, but that's all right. Interesting. I don't think anyone's ever pointed that out before. Number 8 was matching formulas, and so it actually shows the complement with an asterisk, not with a tilde in front. Tilde? Tilde? What's the name of the sign?
Squiggly sign.
Yeah, the squiggle. Thanks. That's what I would call it. Okay, what else besides number 8?
40. Is that 44? Solid.
Ooh, it's like an Uno deck. Okay. Number 44, let's talk about it. Do you guys have the information for me? So we have a deck of cards. How many total? This is 44, yeah? Okay, so we have total cards, 108. What else do we know?
Yellow, green. 25 for each of them.
Red, yellow. Oh, yeah, it's just like Uno. Green.
8 wild cards. Rip off the Uno. Don't. Good joke, John. Like that.
So it's like Uno, but they didn't go into all like the draw 2, draw 4 reverses. They made it a lot easier. Okay, so what are they asking us for? Part A says, what is the probability a hand will contain exactly 2 wild cards? Now, a hand. Do I care about the order they were picked up in and all the way the player can arrange them, or just looking at it that there are 2? Yeah. So combination or permutation? Ooh. Wait. Do we care what order they are? So combination. Combo pizza. We don't care the order, just that that's there. Okay. So combination. And we're looking for the probability of exactly 2 wilds. Now here's the struggle. Do they only have 2 wilds? No. So think beyond just what they said. Technically, what are you going to have in your hand? 2 wilds and 5 colored. Sure, that works. We call these the colored cards. Okay. So 2 wilds and 5 coloreds. Now, how do we think of the 2 wilds and the 5 colored cards? They could be any color: red, yellow, green, blue. How do we think through and? You said combination. I had to split up the numerator to be the wild scenario and then the colored scenario. I'm doing the multiplication because they're being put together. 8. Good. Out of the 8, how many groupings of 2 could I get? Not arrangements, but groupings. And then out of the 100 colored cards, all 4 put together, getting 5. What's the sample space? Perfect. Does that make sense? You have to think about the 2 wilds. Well, you would have had to have 5 colored cards. I don't really care the arrangements, so I'm just going to use combinations the whole time. And that should work out well. But there is a part B, isn't there?
Yeah.
Okay, what's part B ask?
2 wild cards, 2 red cards.
Ooh, it's more specific. So take a second and then think of what you guys would do now knowing what you've seen me do for A. So 2 wilds and 2 red?
Yeah.
And? Okay. Take a second and set it up. While you guys are setting that up, do we have another question on deck? Makes sense in context of the chapter. Like a batter on deck, but a problem on deck. No other questions? Okay. You guys ready? This one's actually kind of nicer because it literally sets it all up. Wouldn't the sample space still be the end, or the denominator? 108C7? How many different groupings of 7 cards are possible? Did you guys do 8C2 times 25C2 times 25C3? Dun, 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 dun. Plug-in in cells? Would this be a calculator problem? Yes. Wait, on the test, hold on. I know it's not until Friday, but on the test, if you're allowed to use your calculator for word problems like this, do you think I'm going to split it up in calculator, non-calculator? I could have, but I didn't. But hold on, wait. If I'm not making you do anything by hand, some of you might think, oh, we don't have to memorize NCR or NPR or factorials. Well, factorials, hopefully you know what those are. Binomial theorem, oh, you should still memorize that. That's not the calculator. Would I, could I, how could I test you on knowing the formulas if you're allowed to use your calculator? I could have done a formula quiz, but I was like, I'm not sure if there's as many formulas as like the trig ones, so I'm like, that seems kind of annoying. I could just say something like, show all your work the whole test, and you should show it somewhere. But here's what I actually did. I have in some multiple choice questions or some long answer questions, I have blanks like show me the A sub n formula, show me the S sub n, show me the NCR formula that you're plugging into. Now, could you check the answer that you got it right on your calculator? Yes. But why am I saying A sub n and S sub n again? What chapter are we in? Probability. No, where did we start? Probability was the end. We started with sequences and series. So why am I warning you of that today? What should you probably start doing tonight? Go back and find those formulas for the nth term of an arithmetic, or the nth partial sum of an arithmetic, or the nth term of a geometric, or the nth partial sum of a geometric. Now, are there tons of formulas? No. There's pretty much those 4 together with the infinite sum of a convergent geometric, the limit as n goes to infinity. There's those 5, and then there's the and, or, complement, combination, permutation, binomial theorem. Well, there are a few, but they're not necessarily as bad as you think. And I will let you use your calculator the whole time, so don't make any silly mistakes in using the formulas, but I do want to see that you know the formulas. Does that make sense? So I might have a multiple choice where I say, P.S., you better give me the formula. Whenever there's a blank on the test, you should try to fill it in, right? Okay, just a warning so that you guys know, and you can be working on the formulas tonight if you have not already been working on them, and you're going back and reviewing formulas from 9.1 to 9.5. One more time, any questions on the review? Not the review, sorry, on 9.7. All right, we're going to grade the evens really quickly to 9.7 tomorrow once all of you guys are able to finish attempting it. But for right now, let's get down to the review, because what am I hoping you can do tonight? Start studying the formulas and start the review. What am I hoping tomorrow can mostly be? A few details about the test, but then otherwise, oh, that's not going to help you. That is not your review. Lo siento. Hold on. Oh, there it is. Go team. It's shorter than the matrices one. But did it prepare you if you did it well? Yeah. Should have anyway. Okay, if I were you, I would write down the test review. Some of you still need to finish 9.7. It is what it is. But since we do have a couple minutes left, and I don't want anyone to have to come running up here to grab a book to do anything productive, because by the time you come up and the time you go back down, let me just throw up the first page put up on the screen the first page of the review. So even if you don't want to write it down yet because you're not quite ready, you can already start pondering where review starts. How about that? P.S. Quick heads up, I am not here after school today. Because I'm not planning to be here after school today. So if you need me, pop in quick to lunch, but there is naps and nuggets, so you might not be able to get much answered, but and then we're in chapter 9, aren't we? But tomorrow I should be here during lunch, during period 7, and after school. Just today, it's kind of like all those free times are kind of taken up. So here we go. You guys have the review written down? All right, here's the beginning of the review exercises if you guys want to start playing with them. Maybe you're just highlighting formulas from the beginning of chapter 9. That would be a great idea too. You could do that instead. Go through and find all those formulas you need to be studying. If you have any questions, let me know.